Good day everyone. We will discuss about SQL Server query hints in this video. Let's get started. I'm going to use database JBSWiki for this demo. I've already created table 1, table 2, table 3, table 4 and table 5 for this demo. I'm going to switch on statistics IO on. I'm going to enable the execution plan and then I'm going to execute this particular query here. Yep, so this query is basically joining table 1, table 2, table 3, table 4, table 5, and we have the join conditions, and then we have an group by and also an order by. So let me execute this query. So the query completed. I'm not going to look into each and every operator on this particular execution plan. I'm interested on the query hint. So let's look at the select operator properties here. And what I'll be interested is like we have something called the reason for early termination of statement optimization, which is set to timeout here. So what it basically means is like we know that the optimizer is a cost-based optimizer, and also we know like it gives us a good plan. It is not going to give us a best plan. That is because we have a threshold time limit for the optimizer to come up with a plan, because optimizer cannot indefinitely check for the best plan for each and every query. So we have this threshold time, and within that time the optimizer has to come up with a good plan. Yeah, now if we see that there is a reason for early termination of statement optimization is set to timeout, then we know like there can be a better plan than this. And as soon as I see this one, that is when I will be going for any kind of query hints. If I'm seeing that the reason for early termination of statement optimization is good enough plan is found, then adding hint to the SQL query doesn't help at all. And I just start adding the SQL Server query hints only if I'm seeing this reason for early termination of statement optimization is timeout. So now I know like it is set to timeout. So what I'm going to do now is like I'm going to add a trace flag called 8780. So 8780 is going to give some more time for the optimizer to look for a better plan. So let's try executing that. You guys can look at it for this particular trace flag, but this trace flag basically gives some more time, like it basically increases the threshold time for the optimizer. I would never ever enable this trace flag on the instance level. I will just be doing it on the query level if I saw a timeout as far as the early termination is concerned, the one that we saw earlier. So let's execute it. Let's go to the execution plan. Let's again look at the properties. So now if I see here, what I'm able to check is like I'm not able to see that particular information, which basically tells like the optimizer timed out. So that means like the optimizer did not time out in this case. So the extra time that we gave using the trace flag has really helped us. It allowed the optimizer to take some more time and come up with a better plan. Yep, that's one hint that we can use in case if you see a timeout. The next one is like let's look at this particular query where I'm forcing an hash join. So let's execute this query, and if you look at the execution plan, you will see that we have forced an hash match join. And if you see here, all the join conditions, all the join operator would be hash match. So again, as I told you earlier, whenever you see there is a timeout, let me execute the query one more time, and then that way you will be able to understand that. If you looked at the reason for early termination of statement optimization is set to timeout, that is when you will have to go for query hints. And in this case, I just wanted to demo like the different type of query joins. I'm not going to include each and every query hints. I'm going to include the hints that I usually normally use in my query optimization. So the first one was query trace on 8780, and the second one is hash join. As soon as I use an option hash join, what happens is like it basically forces all the join operator to be hash join. So there is one more thing that we can do instead of giving an hash join for each and every join operation. What else we can do is like let's consider if we want an hash join between table 2 and table 3, then what we can do is like we can just type inner hash join. And if you look at this one, let's remove this particular hint here. I've just given hash join between table 2 and table 3. So let's run that. Let's go to the execution plan, and if you see here, we are seeing merge join. We are seeing, like, basically we are seeing a lot of merge joins. But if you see here between table 2 and table 3, what I'm able to see is like there is an hash join here. Yep. So that is one way of just for selected operation, we can convert it to a hash join. And then for this particular query, I've added an option that is the hint to go for a merge join. So let's execute that, and then let's look at it. Now, if you see here, what happens is like all these join operators are merge joins. I'm not telling like it is a best practice to do it. I'm just showing you guys like how do we use the query hints here. Okay, and now let's execute this query without any kind of hints. If I run this particular query, what we can see is like we are able to see like the first one in the join order is table 5, and then comes your table 2, then table 3, and then table 4 and table 1. So, but if you look at the query here, we start with table 1, then table 2, table 3, table 4, and table 5. So in case if we want to enforce the join order that is present on the query, then what we basically have to do is like we have an int called force order. And if you look at the query, you can see now like table 1 is not the first one here. So now it has enforced the join order that is present in the query, and you are seeing that table 1 is first, table 2 is second, table 3 is next, table 4 is next, and then comes your table 5. So that is what force order hint basically do. So what I've seen is like whenever I saw a timeout as far as the execution plan generation is concerned, I have seen cases wherein the join orders have changed. I've seen cases where force order has really improved the performance. Again, all these join hints or all these query hints needs to be tested properly on the non-production server. And what is important after that is like, let's consider query is improved by these query hints. You just can't leave it. You basically have to periodically come back and check if these hints are basically helping, or whether these hints are basically going for a regression. So you have to periodically check. That's the problem with the query hints. It is always good to leave the optimizer to do its work. That is why we have a great optimizer that basically creates the execution plan. Now, when you add these query hints, what happens is like you take this power of optimizer wherein you don't allow the optimizer to think for you. What you do is like you think and then you ask the optimizer to abide with what you are thinking. Sometimes it can go horribly wrong. So that is the reason I'm telling like you need to test it very perfectly on the non-production. If everything is okay, move it to production, but you have to periodically check whether it is working fine or not. Moving on, let's execute this query where I'm selecting column 2 and column 3 from table 3, and the predicate is column 4 like a percentage. So let's execute that query. Now, if I look at the execution plan, I have a cluster index scan. So what I'll do is like, now we have the predicate on column 4. So what I'll do is like, I will go ahead and create an index, non-cluster index on column 4. So let me execute that. And then what I'll do is like, I will go ahead and execute this particular query now, hoping that we will be seeing an index scan or an index seek. So let's look at it. Now what I'm seeing is like we are still seeing a cluster index scan, not an index scan or index seek on the non-cluster index that we have created. So what I'll do is like I will use a query hint where I will force this particular non-cluster index that I've created. Okay, so let's execute that query. And then if I look at the execution plan, what I'm basically seeing is like I'm spending close to 100% cost on just the key lookup. So what is happening? Index seek, since we have the index on column 4, it is basically getting the information from the non-cluster index ix underscore test. But as far as the details of column 2 and column 3, since it is not present on the non-cluster index, it is basically going back to the cluster index and getting the information. So this key lookup, which is happening on the cluster index, is going to be a complete scan. It is basically like going to read each and every row, and which is very, very costly. Since this is very costly, SQL Server decided that it is better we go ahead with the cluster index scan, which is comparably less costly than this particular thing. That's the reason I've updated earlier that it is always good to leave optimizer to do its job than adding these in. So it's kind of a double-edged sword. So you basically have to check it perfectly, and then you need to go for a recommendation. And it is very much required that you need to come back and check all these hints and check if these queries are performing optimally. That's it for this video. Thanks for watching. Have a great day. Jai Hind.